Okay, welcome back, kiddos. Now we are moving on to 9.3. We're going to talk about similar right triangles. All right, so first off, let's talk about that keyword similar, right? We know similar means same shape, different size. Okay, same shape and a different size. That's exactly what similar means. So, our essential questions today is how are the altitudes and geometric means of right triangles related? Okay, so that's where we'll be able to answer today. So, let's talk about that first. All right, so if an altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. Okay, so that's a lot of technical terms. What does that mean? All right. So first off, altitude. What does an altitude mean? Altitude is a perpendicular line from the base to the what? From the base to the vertex. Okay. So if we see over here, it says if an altitude is drawn to the hypotenuse of a right triangle. So imagine this right triangle over here. We know it's right triangle because we see this right here. Okay, so imagine this outside triangle. Okay, so actually let me go ahead and do this. So this outside triangle right here. Okay, and we know it's a right triangle because we see this right here. Okay, so the altitude is perpendicular from the base to the vertex. So from here to here. Okay, that's called the altitude. Okay, so when we draw an altitude in a right triangle, it's going to make two more similar triangles to that. Okay, so remember we said similar was same shape, different size. So it's going to make a small, a medium, and a large version. Okay, so if we can imagine this, right? So we imagine the whole thing is this red one. Imagine if I said this one right here on the inside, right? So this one right here. By making that, it makes one that's the same shape but a different size. So we might say like this is the medium version. This is the large, right? And then imagine if I had, say, purple, right? So purple, imagine this one right here, right? So that one would be like a small version, okay? So whenever I made that cut, okay, so I know it's a right triangle, I just went perpendicular, right? So perpendicular means that it has a right triangle, right? That's what that perpendicular means. Okay, it's going to make a small, medium, and large. Okay, so by doing that, we can do proportions to find those ratios. Okay, so that means we can use proportions. Okay, so let's keeping that in mind. Let's practice this. It says identify the similar triangles. Okay, so we see that this is a right triangle, right? This large one right over here is a right triangle. Okay, and then this altitude, right? That's going to be our altitude. It makes into three triangles, one right there and one right there. So sometimes these two are equal, right? So we're still going to consider one to be the small, and then one to be the medium, and then one to be the large. Okay, so we'll say let's do small, medium, and large. Small, medium, and large. So let's identify these. So let's call this one. So let's call this on the big one, right? So on this large one. Let's just go with J where the right angle is, right? That's going to be the middle. So we'll say HJI. Okay, so if we said that's HJI, then we would call that triangle HJI. Okay, now what about the medium one? The medium one would be this one right here, right? So medium, we said we're starting from one side, going down to the right angle, and then there. So on this one, we would start from this side, go down to the right angle, right on the left side. We're saying on the left side of this right angle. So H to J. So HKJ. So that'd be triangle HKJ, right? Okay, now what about this one? Okay, this one, the right triangle would be right there, right? So we said we start from the left of it, we go down and then to there. So JKI. Okay, triangle JKI. Okay, so those would be our answers. That's one, that's the other, and that's the other. Okay, those are the three similar triangles: small, medium, and large. Okay, now let's think about this one. Okay, think about this. Try this one on your own. Okay, so we're gonna try. Let me start with a small, medium, and large. Okay. All right. So our small one. Okay, then our medium one, then our large one. Okay, so we're going to put our right triangle. Okay, so let's look at the large one. Okay, so the right triangle is right over here at M, right? So let's say we're going to start at the left side. Okay, so going down left, then we have the right angle, and then there. So OMN. Okay, so we're going to call that triangle OMN. Okay, now let's say this is the small one. Okay, so this is the right angle, right? So we said we're going to start from the left side of that. So we're going to say NPM. Triangle NPM, right? Now what about this one? We said we're going to start at the left side of it and go to the right angle. So MPO. Triangle MP. Okay? So what we want to do is break it up into small, medium, and large, and then we can identify it from there. Okay, so let's keep in mind, let's look over here. It says a roof has a cross section that's a right triangle. Okay, so this is a roof of a house, right? You see this house over here. Those are the windows. That's the roof. Cross section that it's a right triangle. So if you see this, that's a right triangle, right? We see that right over there. Okay, so the diagram shows the approximate dimensions of a cross section. Find the height. Okay, so the height is this right here. Okay, well, what do we know? It goes perpendicular to the base, so this is the altitude. Right, that's called the altitude, right? Okay, so let's take a look. The large one, right? So the large one would be, right, this whole big one. This is the hypotenuse, right? So that's 6.3. Right? Then, if we find, let's look at this one, right? The small one right over here, right? So, I'm sorry, the big one and then the back, right? The large one is 5.5. Okay? And then the small one's 3.1. Okay, so those are the three sides. All right, so now we want to find this. Now, since that's an altitude, I know it makes a similar triangle. So let's look at that. The hypotenuse of that smaller one, right, is 3.1. So I know that goes right over there. I'm trying to find this right here, right, which is going to be the longer piece, right? I'm trying to find that long side. So if I'm trying to find the long side, that would be x, right? That would correspond with there. So since I know that they're similar, I can use proportions. Okay, so I can say, let me set up my proportions. So I can say 5.5 over 6.3 corresponds with x over 3.1. Right? Okay, so now let's just do my cross multiplication. So I would have this times this, right, which would give me 6.3x equals, okay, this times this, which if we type that into our calculator, that comes out to 17.05. We know our last thing is to divide by 6.3. All right, so that means x is approximately 2.7 meters. Okay, so what we would do is we would just set up a ratio. Once we know that there's small, medium, and large, we think back to what we did before where we do those. Okay, so that's our first skill, talking about doing these similar triangles. Okay, so now let's talk about the geometric mean. Okay, so we're going to shift gears just a little bit. Now, a geometric mean, what that means is for any two positive numbers, a and b, the geometric means is if we solve for x, okay, in this scenario. Okay, so x is going to be equal to the geometric mean. Okay, so it says find the geometric mean between these two numbers. All right, we said we're going to use this setup, so let's go ahead and just set up our fractions. All right, we're trying to find the geometric mean, so that's going to be our x. Okay, and then let's use those two numbers, right? We said that's going to be the A and the B. So let's go ahead and write those in. So we're going to say 2 and 6. All right, so now we need to solve for x. So let's do our cross multiplication. X times x gives us x squared, right? 6 times 2 times 6 is 12. All right, so now we need to take the square root of both sides, right? So we're going to take the square root of the left side and square root of the right side, so that gives us x, right, equals, now remember, we want to simplify this, right? So the square root of 12 can be rewritten as the square root of 4 times the square root of 3, right? Okay, now let's simplify that some more, right? We know the square root of 4 can just be written as 2, and then we pop out the square root of 3. So that would be our answer, the geometric mean between these two. So since we have a squared term, we're just going to simplify what we practiced. All right, so see if you can set this one up the same way. Find the geometric mean between these two numbers. Okay, hopefully you tried to set it up so we know that since it's a geometric mean, we're going to do this. We know x goes there, x goes there. We know 5 goes on top, on one, and 4 goes on the bottom. It does not matter the order. All right, so x times x we know gives us x squared. Okay, x times 4 times 5 gives us 20. Okay, once again. Okay, so maybe don't have to rewrite it. I need to take the square root of that to get to x, right? So I have to take the square root of that. So the square root of 20, we know, can be rewritten as square root of 4 times the square root of 5, right? So that means x is equal to 2 square roots of 5. Okay, so that's our answer on that one as well. Okay, so to find the geometric mean, we want to do that. So that's if they wanted it in decimal, in radical terms, right? Now, what if they said, what's the decimal answer, right? So we would just type that into our calculators. So 2 square roots of 3 is equal to 3.456. So it's approximately 3.5, right? So depending on which type of answer, 2 to the square roots of 3 is approximately this, right? What about this? Okay, if we said what is 2 square roots of 5, right? We just push enter. We'd say 2 square roots of 5 is approximately 4.5, right? 4.5. Okay, so that's the difference between radical. This is our radical answer, and this is our rounded answer. Okay, radical and rounded. Okay, and the main difference is this is an exact value, and this is rounded. Exact, and this is rounded. All right, so make sure you do those practices in Delta Math. Now let's go ahead and see exactly what we're going to be doing with these. All right, so the geometric mean theorem. Okay, what that tells us, the length of the altitude is the geometric mean of the lengths of the two segments. Okay, so now imagine we're trying to find this. Okay, that's the altitude, right? We said that's the altitude. Here's how we calculate it. We're going to see the two segments of the hypotenuse. So we're going to say that's going to be, say, like part number 1. Okay, and we'll call that part number 2. Part number 2. Okay, so here's what we do. We're just going to set up our thing. So we're going to say the altitude over there, the altitude over there, the part number 1, okay, and part number 2. Okay, so we're setting it up very similar to what we just did over here, right? All right, where the altitude is right over there, it's the same thing as where we would put that geometric mean. Okay, so I'm going to put the altitude there, and then whatever the two parts are right over there. All right, so let's keep that in mind. Let's go ahead and take a look at this problem over here. It says this, given this right triangle ABC. So ABC, right? And we know it's a right triangle because we see that right there. Okay, has an altitude of BD. Okay, so the altitude is this right over here. Right, so that's our altitude. Okay, so it says AD is 12, right? This much is 12. Okay, DC is 16. What's the length of BD? Okay, well, we just said, right? If we want to calculate this, we're just going to set up our proportion just like this. So let's set up our proportion. Okay, so we said the altitude is the altitude is going to be right there and right there. Okay, so the altitude is right here, right? That's what we're trying to find, right? So let's say that's x, right? We're going to label that x. So that means x goes right here and x goes right here. Okay, now we said the two parts, right? This is one part and this is the other part. So this creates, right? This creates two parts right over here, right? So we have this is part number one, right? And then this is part number two. Okay, so that's created by that altitude. So let's look over here. Okay, part number one is 12. Okay, so part number one is 12, right? Part number two is how much? 16. Okay, so we're going to put that there. So that's what we do is we figure out the parts, we put it there. Now let's just do our cross multiplication, right? So we said x times x, we know that's x squared. Okay, so 16 times 12, let's go and put that in our calculator. Okay, so make sure you pull up your Desmos with me. 16 times 12, so 16 times 12. Okay, we get 192. Okay, now we know what to do next, right? We're going to take the square root of that to give us x. So that means I need to take the square root of that. Okay, but they want it in radical form. Okay, so I could put that in my calculator, right? Square root of 192. Okay, so if they wanted a decimal answer, that would be the answer. But they want radical, but not just radical, but simplified radical, right? So that means we want to find the largest perfect square that goes evenly into 192, right? So let's type that in. We're going to say 192, right, divided by 192. Okay, divided by, okay, so we'd start with 169, right? Okay, so 169 is no good. All right, then what? 144, right? No good, right? Then we would try 121. Right? No good. Then 10 would be 100. We know that can't work, right? Because it would be 100, 200, right? 300, right? So then we said 81. Okay, 81 doesn't work. Okay, then we would try 64. Okay, 64 does work. So 192 divided by 64 is 3. So that means we would say 64 and 3, right? And that's how we would check our work. We would say 3 times 64 is 192. 3 times 64 is 192, and backwards is that, right? Okay, so now we're just going to simplify that, right? So that means the square root of 64 is 8, right? And then we bring down our last part. Okay, so let's check that out. If I put that in, 8 square roots of 3, it should be the same as this, and it should be the same root as that, right? So 8 square roots of 3. That's how we can check our answer. This is the same thing as this, which is the same thing as that. So that is our answer in simplest radical form. Okay, so keep that in mind. Let's keep it moving. All right, so see if you can set this one up. All right, so this one says, given this right triangle ABC, okay, we know that's a right triangle, with the altitude of BD, okay, so that's an altitude. If AD is 6, okay, and BDC is 11, right, what is the length of BD? So BD, so this right here. Okay, well, let's check that out. This is, it says it's an altitude, right? So that means if we're trying to find that, then we can use our formula, geometric mean. So let's set that up. Okay, so we said the altitude, right, goes one on the bottom, one on the top. So I'm going to put x there, and I'm going to put x there. Okay, then we said part 1 goes over there. So part 1, let's just say 6. Okay, and then we said part 2 goes over there. So the other part is 11. Okay, now just keep it going, right? X times x gives us x squared. Okay, 6 times 11 all day we know is 66. Okay, so now let's see if you can simplify this. All right, let's try that out, right? We should have said, hopefully you tried, right? So we said that's x, right? So now let's try to find the largest perfect square that goes evenly into 66. Now let's check this out, though. And so if we say, let's move this over here. Okay, so if I say 66 divided by 49, that doesn't work, right? So then by 36, right? That still doesn't work. Okay, so then what about 25, right? Okay, that doesn't work, right? Getting, let's see, 16. 16. No, that doesn't work, right? What about 9? No, because we know 9 times 7 is 63, right? That won't work. All right, getting close. What about 4? 4 still doesn't work either. So the only one is 1, but anything can be divided by 1, right? So here's what we found out. Sometimes it can't reduce. Okay, that's this example. Sometimes it can't simplify. We tried, but couldn't do it. All right, so now here's a different variety. Okay, so this one right here, they were looking for the hypotenuse. Okay, so we're trying to find the altitude. I'm sorry, we're trying to find the altitude on this one, right? Find the altitude. Okay, so now let's look over here. This one says, given this right triangle, okay, with the altitude BD. All right, so that's our altitude. All right. If AD is 5, okay, so this much is 5, and BD is 10, okay, this much is 10. What's the length of DC? Okay, so now this is we're trying to find a part. Okay, so this one we were trying to find the altitude. Okay, so this one trying to find the part. Well, if we're dealing with the altitude, right? Here's what we know. If we're dealing with the altitude, then we can still use our geometric mean because we're dealing with the two parts in the altitude. So let's set it up. What do we say? Altitude goes one on the bottom, one on the top. So the altitude is 10. So now we're going to put 10 there and 10 there. Okay, so the altitude goes on the bottom and the top. Okay, so now what did we say? We said the first part goes up there, so the first part is 5. Okay, and then the second part goes there, which is what we're trying to find. So that's the x. Okay, so once we set it up, now we're good. All right, 5 times x gives us 5x equals, all right, 100 times 10 gives us 100. Now we know we're just going to divide by 5, so x equals 20. Okay, so sometimes we get that, but we're just thinking, are we looking for a altitude or looking for a part? All right, so look at this one, see if you can at least set this one up on your own. All right, this one says, given this right triangle, altitude is BD. Okay, that's an altitude, so we know that that's a right triangle, right? Hypotenuse, if AD is 48 and BD is 24, right? That's our altitude. BD is 24. What's the length of AC? Okay, so it wants to find, it wants to find the whole thing, right? That's what they want to find. So this is find the hypotenuse. It's the whole thing. All right, so this is that variety. All right, so let's take a look. What are we dealing with? This, to find the whole thing, okay, so first we need to find the part. Right? So if we find this part right here, then we can add it to this, right? So the second thing is add to other part. Okay, and then that's our then we calculate x. Okay, so let's take a look. What do we know? If that's the altitude, that means we can set it up using this proportion. So let's do that. Okay, so we said the altitude, one goes over there, one goes over there, right? So if the altitude is 24, one goes there and one goes there. So 24 and 24, right? Okay. Now, it says one part goes there, so one part right there is 48, right? And we're trying to find this. So let's call that y. Okay, because that the whole thing is x, right? So let's call it y. It doesn't really matter, right? Because it's just a number that letter that we're using to represent something. So now let's do our cross multiplication. 48 times y is 48y, right? And then we have 24 times 24. So let's go and type that into our calculator. Okay, so we got 24 times 24 gives us 576, right? Okay, so let's type the 576. Now we know what to do. You're going to divide by 48, right? Okay, so that means y equals, so we're going to go 576 divided by 48. And that gives us 12. Okay? All right, so that's step number 1 that found our part. Now step number 2 says we need to add it to the other part. So we're going to say the first part of 48 plus our 12. Okay, and then that gives us the answer of 60. Answer is 60. Okay, so all we have to do is just follow those steps. So here's what I got. I got 3 different varieties for you. So let's get a good color that we're going to see these pop. To find the altitude, we're going to follow this example. To find the part, we're going to find this example. And then to find the whole hypotenuse, we're going to use that. So we're going to find the small part, then we're going to add it to the other part to get to the whole thing. To figure out the one part, we're going to set it up. To find out the altitude, we're just going to set it up. All right, so that leads into our last part. So these are the trickier ones, just because they're set up a little bit differently, but basically the same thing. Okay, so find the part of the large hypotenuse. So this is the large one right here, right? And we're trying to find x. It says given this triangle, okay, altitude is BD, right? If that's an altitude, we know that's a 90-degree angle. Okay, if AD is 9 and BD is 12, okay, what is DC? Okay, how would we do that? Well, we know we can use the geometric mean. Okay. All right, so which we know is altitude, altitude, part number 1, and then part number 2, right? So altitude, altitude, part number 1, part number 2. And let's cross multiply, right? 9 times x is 9x. 12 times 12 all day is 144, right? We've been practicing that. Divide by 9, divide by 9. All right, let's type it into our calculator. That one's a little bit more difficult to do in our heads, and that's okay. That's what main thing is, type it in. So x is 16. So that's the length of DC. All right, so now here's the last one, and this is a little trickier, but we got this if we follow our simple steps. Okay, so it says given the right triangle of ABC, right, the big one, ABC. If AD is 5, okay, AD is the short part, okay, and AC is 55, okay, so that's the whole thing, right? What is AB? So AB is this right here. So on this one, we're trying to find the short leg of the large triangle, right? Because if we notice, this is the large one right here, right? So let's set up a portion of similar triangles. Okay, so let's set this up. We know because that's an altitude that's going to make a small one, and let's do this. Yeah, a small one and a large one. Okay, so the large one, let's look. The right angle is at B, right? So we're going to say that that's B, and then the short one is B to A, right? So let's say that's A. Okay, and then the long one goes up to C, right? Okay, now let's look at the small one. This small one right here, right? This is what we're looking at. I'm looking right over here for the small one, right? So the small one, that right angle, actually is right over there, right? Okay, so that's going to be D. Okay, then to that short one's going to be A, right? And then if this is the short, right? That's the short. Okay, and then A, D, and then B, right? Okay, so now let's set up our proportions. A to D is 5, right? This much is 5. Okay, and they want us to find x, which is across from the right angle, right? That is the hypotenuse, right? So this is what we're trying to find, right? So now let's see if we can set up a similar proportion. So on this one, on the big one, right? Let's do this just to kind of make it pop well for us, right? If we know that this is imagine that this is the large triangle, right? And if the large one is right over here, the hypotenuse, right, is 55. That goes the whole thing, right? So that's going to be 55 right there, right? Then the short piece on the big one is x, right? Okay, so now we have this and this and this and this, right? So let's set up our proportions. Okay, so we said let's do this. The hypotenuse over the short, so x over 5. Okay, let's do the hypotenuse over the short, so 55 over x. Okay, now let's just cross multiply, right? X times x is x squared equals, okay, 55 times 5. All right, so that's fair if we don't know that one offhand. So let's put that in our calculator. 55 times 5, okay, gives us 275. Okay, now they want the answer in simplest radical form, so that means we need to see if it simplifies, right? So we're going to take the square root of that, which will give us x, which means I need to take the square root of 275. So let's go ahead and find the largest perfect square that goes evenly into 275, right? So we would say 275 divided by, let's try 225, right? That was that 15 squared, right? But that won't work. So let's try 14 squared, which is 196, right? That won't work. Then let's try 13 squared, which is 169. Ooh, 169. Okay, that won't work. Right, then we try 144. Okay, 121. Okay, what about 100? We know that won't work, right? It'd be 100, 200, 300. What about 81? Okay, that's still no good. What about next would be 81, right? Next would be 64. Okay, 64, no good. All right, next would be 49. Okay, that's no good. What about 36? 36, no good. What about 25? What do you think? Well, if we know our 75s, we know if it ends up with a 75, it has to be divisible by 25. So 25 goes in 11 times. Right? So square root of 25 and square root of 11. That brings us down to our final answer of 5 square roots of 11. All right, so that's our toughest one. That's bringing everything together, but I know you can do this as long as we just stay focused. So on this one right here, that's our toughest one. We had to set up those similar triangles. So if we're trying to find the short of the large, right? Trying to find the short of the large, you do that. Otherwise, we're going to think geometric mean for everything. All right, so I know you got this. If you have any questions, just let me know.